even though you have the landing gears down, the warning horn will still sound when the throttles are closed unless you have the control valve in the neutral position. Let you and I prove it. Let's start at the ground and trace the current back to the source. Here we are on the ground in the lower left-hand corner, and we have wire 14. And we have the left gear switch, and the gear is down, so we have this switch closed because this tells you when the gear is down, that switch is closed. And so now we have from the ground through wire 14, the left gear switch being down, and now we have wire 3 here, and the right gear switch is down. We've still got a continuous circuit here, a continuous path. And now, notice that if the control switch is in neutral, it would be over in this position. But if the control switch is not in neutral, other than neutral, it would be in this position. Let's see what happens if the control switch is not in neutral. Then you would have a path for the current to wire 10. Now let's go beyond wire 10 to wire 5. And now, when the throttles are closed, these switches are closed, and now you have a path through the throttle switches to wire 6, to the warning horn, and then through the warning horn, which will now sound all the way back up to the current source. So you see, let's take a look at this switch again. When this switch is not in neutral, the warning horn will sound even though the landing gears are down. And you have just answered the first question about this, and all we had to do was trace our way through it. By the way, it is a good idea, if you've got a book that you can mark in, to use the yellow pen and do exactly what we did to figure out where everything is going. Now, if the control valve switch were not in neutral position, that is the path the current would take. Let's take a look at another example. And we look at figure 18, and the question is, what you need to know is, when the landing gears are up and the throttles are retarded, the warning horn will not sound if you had an open or a break in wire number 4. Well, let's take a look at it. We'll start over here in the lower left-hand corner with the ground, and of course the ground is connected to wire 14, which is connected to the left gear switch. When the gear is in the up position, the switch will be over here. Then you're connected to wire 4. Then you have the throttle switches, and when the throttles are closed, these switches are closed also, so you'll go through the throttle switch to wire 6. Then you'll, of course, go through the warning horn. Then the warning horn is connected back to the power source, and you can see the warning horn would sound. So if you have a break in wire 4, all of that's not going to happen. So you can see the warning horn will not sound even when the gears are up if you have a break in wire 4. Now they're going to give you some other options. They'll say, well, how about if you had a break in wire 2? Well, if you look at this diagram, wire 2 has to do with the red light warning circuit. So that doesn't have anything to do with the warning horn. And they say, well, how about wire 9? Well, wire 9 has to do with the green light circuit. So that doesn't have anything to do with it. And how about wire 10? Well, wire 10 has to do with the control valve circuit, and that doesn't have anything to do with it. So the correct answer is the horn will not sound if you have a break in wire 4. Now let's take a look at figure 19 and take a look at some questions you're going to ask about figure 19. Here's an answer to one of the questions. Let's follow it through and see if we can make some sense out of it. The answer is, the condition which will provide a ground for the warning horn through both gear switches when the throttles are closed is only the condition that when the left gear is up and the right gear is down. Now, there are other ways for the warning horn to sound, but this is the only way that it uses both gear switches. Let's take a look at it. First of all, we'll start with the ground in the lower left-hand corner of the drawing, and then we have the right gear down. That was the condition, and this arrow tells you the right gear is down when the switch is over in this position. And then we go along wire 5, and the left gear had to be up for this condition, if you remember. Now, this drawing is shown with the left gear down, but put the left gear up, and now you have a contact through here. And then we go along wire 12, and these are the throttle switches. When the throttles are closed, we have a route to a wire 11, and the warning horn will sound. And then you go through wire 10, let's complete the circuit, and back to your 28-volt DC source. So the only route that provides routing through both gear switches for the warning horn to sound is when you have the left gear up and the right gear down. Now, if you have other situations with one gear up, you'll still have the warning horn sound. It'll just provide a different route for it. And that's the way they're going to ask you about this on the test. Now, here's another question they're going to ask you on the test. It's very similar. They'll say, take a look at figure 19. And what would happen if you had that same situation? You had the right gear down, the left gear up. What would happen if you had an open in wire 5? Well, if you had an open here in wire 5, you've broken the circuit and the warning horn will not sound when the throttles are retarded. So if you have an open in that circuit, obviously it's not going to work. So if you had that same situation, and that same situation is the right gear down, a left gear up, had an open in wire 5, the warning horn's not going to work properly. Now, figure 19 is pretty complicated, so therefore the FAA loves to ask you questions about it. So they're going to ask you yet another question about figure 19. Now, here is the question. When the landing gears are up and the throttles are retarded, the warning horn will not sound if an open occurs in wire number 6. Now, the reason for that is only the right gear switch sounds a warning horn when both gears are up. Let's take a look at it. First of all, when the right gear is up, this switch is over in this position. Now, notice we have wire 5 here, and when this right gear switch moves to this position, it disconnects wire 5. So wire 5 is not connected on the left end. Remember that. We're going to talk about that later on. Okay, now we do have a path from the ground through the right gear switch over here to wire 6. So we'll continue across on wire 6 and we go up through to wire 12 and then we go through the throttle switches. You can see that sounds the warning horn by going, of course, the warning horn is connected by 10 to the power source there. So you can see that if you do have wire 6 with a continuous connection in it, that the warning gear will sound, or the horn will sound when the right gear is up. And the left gear is also up. Remember, the left-hand side of wire 5 is not connected. Let's go over here and see what would happen. And even though the left gear switch is up, it's only connected to wire 5 through wire 12. It's not grounded. So the left gear, when both wheels are up, does not sound the horn. It's the right gear switch that sounds the horn. And if the wire 6 is disconnected, then neither one would sound the horn. So what they want you to know is, in this particular drawing, if you have an open in wire 6 with both gears up, the horn won't work properly. And that's the answer to that question. Now let's take a look at figure 15. And the thing you need to know about figure 15 is very simple. What does wire number 7 do? And the answer is it's used to complete the push-to-test circuit. Well, let's take a look at what we're talking about here. First of all, we have the bus on the left-hand side. Wire 7 will go around here. We'll trace this in more detail in just a second. And then you get over here on the right-hand side, a couple push-to-test switches and lights, and then finally a ground. So what we need to do is complete the circuit from the power source to the ground. All right, let's start over at the power source. And here we have a bus with a 5-amp circuit breaker and then wire 7. So you can see wire 7 is going to be instrumental here. It comes right from the bus. And then we go through wire 18, and then here's a light with a push to test, and when you push on it, you complete this circuit here, and then it goes all the way over to ground. And you can do the same thing through wire 17 for this light. Push on it, and you complete a circuit all the way to ground. So you can see that wire 7 does complete the push-to-test circuit. Wire 8 is the normal source for providing those lights as a warning. So wire 8 would be the warning power source for those lights, but wire 7 is the push-to-test power source for those lights. And that is a simple one. Let's complicate things up by taking a look at another question in figure 15. This time they ask you to know this. With the landing gear retracted, the red indicator light will not come on if an open occurs in wire 19. Well, we've already kind of referred to that. Let's take a look at it. The landing gear is retracted, so we'll start off with the power source over here. And we'll take a look at wire 19. And if you have the landing gear retracted, this switch is in the up position. And so now you have this switch in the up position, and we go through wire 8. And wire 8, as we said earlier, will light this red light because it's connected right to the red light, and then that goes to ground. So you can see that wire 8 is our path. Now let's go back and make sure that we've answered the question. And what you need to know is if there is an open in wire 19, none of that will happen. And they ask you that on the test. So what you would do is troubleshoot and look for an open in wire 19. And then if there is an open in wire 19, the red light would not illuminate. Those are typical questions they're going to ask you about this. Let's take a look at one more question on figure 15. And what you need to know in this case is when the landing gear is down, the green light will not come on if an open occurs in wire 6. Well, let's take a look at the circuit when the landing gear is down. First of all, we'll start over here at the bus and we'll go through this 5-amp circuit breaker. We'll go down here into wire 6 and the nose gear is down, so the switch is in this position. That's the nose gear down switch, and that makes contact with wire 5. The left gear is down, and so we have that switch closed. And number 4, wire 4, and the right gear is down. That switch is closed. And then we go through wire 3, and of course the green light will now operate because we have a connection all the way to ground. Now, the question is, what happens if wire 6 has an open in it? Well, if wire 6 has an open in it, none of this will happen because the current will get broken right at the start of its travel. And you can see that if we had an open in wire 6, then the green light would not illuminate. Okay, you guys are doing just absolutely fantastic at this. Let's take a look at fuel system circuits. And to do that, let's you and I take a look at figure 16. Now, there are some things that we need to explain about figure 16. First of all, what you do on all of these drawings, you find your power source. Your power source is up at the top, and then you go to some grounds. Now, we need to talk about a couple concepts. We need to talk about relays, and we need to talk about solenoids. So to talk about relays, let's start off on the left-hand side and follow the normal power source. This is what happens when things are normal. Now, first of all, you have power at this bus. It's a 24-volt bus. You have power at this bus. Here you have a circuit breaker. And in the normal position, everything goes right straight down. You see this switch is a switch over here, but it dead ends at this terminal 4. And so in the normal position, everything goes right straight down this direction. Now, this is the concept of a relay, and let's take a look at it for just a second here. First of all, notice that we've got a ground right here. And what happens is, if there were power to this relay, this switch, this whole assembly would move over. A relay is an electromagnetically controlled switch. And if you put power on the electromagnet, which is what you have right here, an electromagnet, a coil of wire, then you're going to pull both of these switches over. Now, we have this drawing shown with everything without power on it. Here's the way switches look when they don't have power on it. Now, this LTS relay then, when it has power on it, pulls over switches 5 and 6 to this position. They are shown in a position without power on it, so switch 5 would open and switch 6 would close. But as it is right now, there is no power to the LTS relay when things are normal, so switch 5 is closed, switch 7 is closed, switch 9 is closed. None of these relays have power on them. Now let's get down here and talk about the concept of a solenoid. A solenoid is very much like a relay. It's an electromagnetic switch controlled with an electromagnet, but a solenoid has the core move in and out of it. It's got an iron core that can move in and out, and you can use that core to move big things like valves. Now, so this could be, for instance, operating the crossfeed valve. Solenoids, as a general rule, are bigger than relays, and they can operate other things like valves in addition to just little electrical switches. Now, here we have a solenoid. When this solenoid has power on it, what happens is that the whole thing moves over to the right, and switch 12 becomes activated. It changes its position over to this position, and switch 11 becomes activated and moves over to this position. And that opens switch 11 and closes switch 12 in this particular case when this solenoid is activated. But remember earlier I said that this drawing now is shown without any power on it. So without any power on it, we have a path right down here, through switch 11, which is not activated, and we'll go right along this wire up here, and then we'll go back up towards the top of the drawing. And we have now, finally, one relay that has power to it, and that is the PCC relay. And the PCC relay then would open this switch so that there would be no way that power could get on to turn on this light, which is the fuel pressure crossfeed valve open light. And so when things are normal, this PCC relay is activated. Now let's take a look at what other relays might be activated. And let's zoom away and take a bigger look at this drawing, see where our paths are. What we did was we just now went on a path from the bus through all of these relays, and none of them have power on them, so we have a straight shot through these relays, and the solenoid doesn't have power on it, so we're going through this position right here on switch 11, right here to operate the PCC relay, and that will open this switch right here. Now on the other side, we have the 24-volt bus up here, and we'll have power going down this direction like so. And let's take a look at where that power goes when we get down here. And first of all, we have a relay that has no power on it. That's a crossfeed relay, and I'll show you later that only activates when you have crossfeed for the tank crossfeed set on. We don't have it, so there's no power on it, so that switch will be closed. This solenoid has no power on it, so this solenoid only gets power on it, by the way, when the tank crossfeed switch is activated. And so we have no power here, so we're going to go through and we're going to have these switches in a no power position, which is where they are right now. And we'll go through this switch, and we'll go across here, and we'll come up here, and let's take a look and see if we have power on any relay. And son of a gun, we do. We have power on this relay right here, which is the TCC relay. So we do have power on that TCC relay, and that means this valve right here, this switch would open, and the fuel tank crossfeed valve light would not come on. So if you are in the normal situation then that we just described, the PCC and the TCC relays would be energized. And what we're talking about here is they would have electrical power to them. When we're talking about a relay being energized, it has electrical power to it. Now, when it's not energized, the spring holds the relay in the opposite position. When there is electrical power to it, the electromagnet pulls the relay over like so. So you can see that these are the two routes of current. Let's take a look over here on the left-hand side. We have the crossfeed relay right here, and this is the fuel crossfeed relay. And that only gets activated when the switch up here at the top, and here's the switch up here at the top, is in the crossfeed position. If it's in a crossfeed position, then power comes over here. So you can see that this crossfeed relay, when it's on, then would pull 9 and 10 over, and it would also activate the far right-hand side down here and pull 17 and 18 over. And it would also then activate at the same time 19 and 20. Since that relay is not activated, that's why we don't have to worry about the path changing here. So what we have activated when things are normal are the PCC and TCC relays. Then they're energized. All right, now let's take a look and see what would happen if you move the fuel selector switch to the right-hand tank. Okay, we'll start up here at the bus, and here we are up the bus up here like so. And let's get in a little tighter and take a look at how we're going to move this to the right-hand tank. And here we are. We'll move this switch to the right-hand tank. What it would mean is you start at the bus, you go through here, now you have a connection to this position right here. And that means the power is going to take this direction right here. So let's take a look and see where it goes. And when that happens, the RTS relay is energized. Now, the LTS relay is not energized, so the current is coming from the bus right straight down here. But when the RTS relay is energized, switch 7 is moved to the left, and that's an open. And now switch 8 is closed, and now we have a path that goes like this for the current. Now, since we have a path that goes like this for the current, we hit terminal A here, and that means this whole solenoid is activated, and switch 12 will close and switch 11 will open. Now, since switch 12 is closed, we're going to go this route back up through terminal C, and the PCO relay is energized. And when the PCO relay is energized, switch 13 is closed, and power comes from the bus right through here, and then the fuel pressure crossfeed valve light would be open in that particular case. All right, now let's take a look at where else the current is going in this particular case. And we'll start up again at the upper right-hand corner. And when you get in the upper right-hand corner, taking a look at that, there we are. We're at the upper right-hand corner. And we have the 5-amp circuit breaker. The power comes down here. And remember, the fuel crossfeed relay is not energized, so we're going to write the same circuit to figure through switch 20 here. Everything's just the same as it was. We're going to go back up here through terminal D, and we find out that TCC is still energized. So now the question is, what relays are energized when you switch to the right-hand tank? Well, we said TCC is energized. Let's take a look at what else is energized. And if you take a quick look at it, RTS, let's zoom in a little tighter and make sure we're looking at RTS. RTS becomes energized. And then also PCO becomes energized. PCO was way back up here, and PCO becomes energized. So you see, if you switch the right-hand tank, the relays RTS, PCO, and TCC become energized and they have operated. Well, wait a minute. I can hear you asking right now. You want to know what happens if you switch to the left-hand position. All right, I could tell you we're going to do that, so let's switch to the left-hand position. We'll start out at the bus, we'll come through this switch, and we'll take a close look here at the valve and make sure that we're in the left-hand position with it. And if you zoom in tight, you see now we have the left-hand tank right here. So now we're at the left-hand tank. Now if you go on down, you can see that we have energized some relay here, and we have energized the LTS relay. When you've energized the LTS relay, switch 5 moves over and becomes open, switch 6 becomes closed. So power, which comes from the top, now goes through switch 6, and it goes to A. Now, this solenoid is now activated when switch A, when we're in terminal A, and switch 12 is activated, switch 11 is activated. And then we're going to go take power up back through C here, and we're going to go up and activate the PCO relay, and that will activate switch 13. All right, now let's take a look again what happens on the other side of the drawing when we put power in on the other side of the drawing, and it's all the same every time unless we operate that tank crossfeed switch. But here we have power coming down from the 5 amp circuit breaker, and once again it goes through the right-hand side of this solenoid back up, and once again, since we haven't operated that tank crossfeed, we're still only going to have one relay activated, and the relay activated is this TCC relay, which activates switch 16. Now, the question they're going to ask you about this is, let's assume you turn on power with the left fuel tank selected. Which switches will be energized or moved? So let's take a real quick look at it and start over and review it and see which switches will move. First of all, you're going to activate the LTS relay, and that will automatically activate both switches 5 and 6. So we know switches 5 and 6 will activate, and they activate as a pair. If you turn on the LTS relay or energize it, you get both switches to activate. Now come down here and you see that we've turned on to terminal 12. We've come to terminal 12, activating this solenoid, and that automatically activates switches 11 and 12. And they act as a pair also. All right, now let's go back up here and see what happens. We've now energized the PCO relay, and all of a sudden that automatically means switch 13 is activated. All right, now we're going to have one other relay that's activated, and that's this relay right here, which is the TCC relay, and switch 16 becomes activated. And there is one more switch that we need to talk about that does momentarily become activated, and that's switch 15. And let's see if you and I can trace out how in the world switch 15 momentarily becomes activated. And we're including this in the answer because all of the correct answers on the FA test refer to switch 15 as being activated. How can we say it would be activated? Well, let's go back up at the top and turn on the power. And what we have selected the right-hand tank, but at the very moment you turn on the power, what's going to happen is these relays have not been activated yet. So there is a path of current right straight down through terminal 11. The solenoid's not activated yet because you just turned on power at that instant, and you're just for a second going to get a flicker of power over here to the PCC relay, and that will activate switch 15. Now, as soon as power comes on, all those relays will activate, and that'll cut off power to switch 15. But for just an instant, we're going to have power to switch 15, and that will operate also, and that's why we include 15 in the answer. Now, the real reason we include 15 in the answer is the FAA has it in all of their answers that make sense, so we know they expected that switch to operate for just a split second there. So the answer to this question is, if you select the fuel tank position of the left-hand position, turn on the power, switches 5 and 6, they operate together. 11 and 12, they operate together. 13, 16, and 15 will all become moved or energized or activated, and 15 is only activated very briefly. Now let's take another look at figure 16, and let's take a look at another question they're going to ask you here on figure 16. And the question they're going to ask you says, if the PCO relay in figure 12 failed to operate when the left-hand tank was selected, what would happen? And the answer is the fuel pressure crossfeed valve open light will not illuminate. Well, let's take a look at the fuel pressure crossfeed valve open light, and it's right here. It's fuel pressure crossfeed valve open, and they're saying if what relay failed to activate? Well, the answer is if the PCO relay failed to activate. Well, here is the PCO relay, and what we're saying is if this relay failed to activate, switch 13 wouldn't work and this light would not come on. And that's the question they ask you about that. What would happen if you did switch to this condition and the PCO relay didn't activate? That means that light would not come open because switch 13 wouldn't come over to provide a path for the current. All right, let's take a look at another question they're going to ask you about figure 16. And here's the answer to this question. That is that TCO relay will operate if 24 volts DC is applied to the bus and the tank selector is this time in the crossfeed position. That's when the TCO relay will operate. Well, let's take a look at it. We start up here at the power again, and this time we're going to send power over here to the crossfeed position. And let's go down right here and take a look at what happens when you're in a crossfeed position. And first of all, in the crossfeed position, the FCF relay will operate. All right, now what happens when the FCF relay operates is that these switches move over, and you have an open on 9 and a closed on 10. So power is coming right straight down from the top, going through 10, going through A. And now this solenoid will activate, switch 12 will close, switch 11 will open, and power will go up here. And we'll get to the PCO relay, and the PCO relay will operate switch 13. But wait, there's more. So let's go back down to the bottom in the lower left-hand corner and take a look at what more there is, because we are also operating the FCF relay, and it's operating switches 9, and we're also operating switches 10, and that same relay comes all the way over here. This same relay comes all the way over here and activates switch 17 and switch 18. Okay, now, when we've got we're asking about, remember, we're asking about the TCO relay, so now we're providing a path. These switches have moved over, 17 is closed, 18 is open, and we're providing a path to A. This solenoid becomes activated, moves over, and now we have A closed, that switch is closed, and now we come up here, and son of a gun, the TCO relay is activated. It closes this relay, or this switch, and now we have that light operating. And so through all of that complicated route, the TCO relay was activated because we have crossfeed on. And if you go back in the lower left-hand corner, you